Hi, today I will explain how electroplating is related to electrochemistry, especially in jewelry coating with gold or silver. Electroplating is a process that uses electricity to coat a thin layer of metal onto another metal. For example, we can coat a cheap metal ring with gold using electroplating. This is a real-life application of electrochemistry using an electrolytic cell. In this process, the jewelry acts as the cathode, which is the negative electrode, and a piece of pure gold is used as the anode, the positive electrode. Both are placed in an electrolyte solution that contains gold ions. When electric current is applied, a redox reaction occurs. When electric current is applied, a redox reaction occurs. At the anode, gold atom lost electrons and become gold ions. This is called oxidation. These gold ions move through the solution to the cathode, where they gain electrons and stick to jewelry surface. This is called reduction. As the result, the jewelry gets coated with a thin layer of gold. This process is important not only to improve appearance but also to prevent corrosion and increase the value of the product. So, in summary, electroplating is an example of how electrochemistry is used in the real life, especially in the jewelry industry.
So I will talk about corrosion. What is corrosion? Corrosion is when a metal slowly gets damaged or worn away because of a reaction with air, water, or other things around it. The most common example is when iron turns into rust. For example, when you leave a bicycle in the rain, so the metal parts can turn brown and flaky like the picture. So how does corrosion happen? Corrosion happens through a chemical reaction called a redox reaction. Number 1 is when metal is exposed to water, and number 2, redox reaction occurs. Number 3, the last one is rust is formed. So let's see the example on the next slide. So here is redox reaction example, rusting of a nail. So when you leave a nail outside in the rain, what happened to the nail? So let's see how it gets. Number 1 is oxidation, which is losing electrons. At one part of the nails, which is anode, the ion reacts like this. Iron atoms become iron ions, so they lose 2 electrons. This part of the nail will start to get rust. This is called oxidation. Number 2 is reduction, which is gaining electrons. The electrons move to another part of the nail, which is cathode, where oxygen and water are present. Oxygen from the air gains 4 electrons. It reacts with water to form more water. This is called reduction. So basically, on a nail, some parts lose electrons, which is oxidation, and the other parts gains electrons, which is reduction. So together, we can get a redox reaction, and it can cause the nails to get rust.
Assalamualaikum and hi, my name is Husna Humaira. Today I will be presenting to you about an application of electrochemistry, batteries. So, what is electrochemistry? Electrochemistry is the study of chemical process that cause electrons to move. It is also the study of how redox reactions can produce electrical energy or be initiated by an electrical current. So, what is a battery? A battery is a device that converts chemical energy into electrical energy using redox reaction. So you may ask me, what is a redox reaction, right? Redox reaction is reaction that happens when reduction and oxidation occur simultaneously. So we have 3 parts. A battery is made up of 2 electrodes and an electrolyte, which together form an electrochemical cell. So we have 3. The first one is the anode. The anode is the negative side of the battery. This is where oxidation happens, meaning electrons are released. And the second one is cathode. The cathode is the positive side. This is where reduction happens, meaning electrons are gained. And the third one is the electrolyte. The electrolyte is the medium that allows ions to move between the electrodes. So how the battery works? So as you can see like the picture given here, batteries work like a galvanic cell, which use spontaneous redox reactions to produce electricity. Electrons flow from the anode to the cathode through a wire, and this is what creates the electric current that powers things like our phone and our remote control. Meanwhile, ions move through the electrolyte inside the battery to keep the reaction balanced. So overall, it's a chemical reaction that produces usable electricity. So we are at our last part of the presentation. Here are some real-life uses of batteries. Batteries are used in many devices around us. Here are some real-life examples and how they work. Smartphone and laptop. They use rechargeable lithium-ion batteries that store and release energy as needed. Second, remotes and flashlight. They use non-rechargeable batteries like alkaline AA or AAA to provide quick power. And the last one is electrical vehicles. EVs run on high-capacity batteries that power on the motor instead of fuels. So, in conclusion, batteries are one of the most practical and important applications of electrochemistry. They power our everyday life from phone to cars, all through chemical reaction that produce electricity. Thank you.